Welcome everyone to this presentation of the turnkey European testbeds towards consistent real-time seismic ground motion and structural monitoring. My name is Benedikt Halldorsson, a research professor at the University of Iceland. I will be giving an overview of the work that myself, but mostly my co-authors and colleagues at various institutes in Europe have carried out while leading the European testbeds of the turnkey project. Now, this presentation describes the turnkey approach in the testbeds. Contributing to the overall objective of the turnkey project, Turnkey develops the turnkey forecasting, early warning, consequence prediction, and response platform, a multi-sensor-based earthquake information cloud-based system. The turnkey platform is demonstrated and developed in 6 European earthquake-prone testbeds. And the basis of the turnkey platform and the project is the consistent approach to the instrumentation using the turnkey multisensor unit and optimizing the real-time streaming of data to a local and central seismic system that provides continuous event and station parametric data to the platform for the various measures of near real-time earthquake effects, impact, loss estimation, and risk. The turnkey European testbeds are, along with their leading institutions in the turnkey project, Bucharest in Romania, the Pyrenees in France, Hveragerði and Húsavík municipalities in Iceland, the Patras and Io municipalities in Greece, the ports of Gio Tauro in Italy, and the Groningen area in the Netherlands. These European testbeds cumulatively provide coverage over a wide range of seismotectonic conditions, earthquake hazard levels as shown in the figure, spatial extents, levels, and types of existing monitoring systems, population densities, and types of stakeholders with various vulnerable infrastructures. It should be noted from the outset that the existing sensor networks in the testbeds vary greatly and use various data management systems. Therefore, the turnkey procedure in the testbeds establishes a consistent procedure for instrumentation, real-time data transfer, and data management, post-processing, and analysis in the testbeds. It starts with the development of the turnkey multisensor unit. The figures show the instruments and examples of the station setups in some of the testbeds. The turnkey multisensor unit is based on a Raspberry Shake 4D, a 3-component accelerometer, and 1 vertical geophone optimized for earthquake early warning, and multisensor connectivity as developed in the turnkey project with the collaboration of OSOP and GEMPA. Moreover, the CAP system, the Common Accusation Protocol server, has been implemented on the turnkey multisensor instruments and delivers the data with minimum latency to the local server using wireless telecommunications optimized by the Síminn telecommunications partner, for example, in Iceland. The multisensor unit thus acts as a connection hub for the other instruments and uses a single communication module that compresses the data and transmits in a consistent data format. The turnkey GNSS sensors that have been developed in the project are connected to the Raspberry Shakes and transmit raw GNSS and telemetry data in real time to the CAP server on the turnkey multisensor unit. Thus, the turnkey instruments are fully capable of measuring the entire ground motion wave field from slow tectonic movements to fast ones, such as earthquakes. Finally, the data in each testbed streams to a local seismic server consistently and to a central cloud-based server at GEMPA for the development of the turnkey platform on the basis of data from all testbeds. The platform will be implemented in each testbed for further testing, development, and evaluation by researchers and stakeholders. Thus, given the various testbeds, each of them has a specific focus and contributes to the corresponding data with the corresponding data to the central system for the development of the platform, thus increasing its flexibility and applicability. The first testbed, Bucharest, is the capital of Romania and is considered the second most earthquake-endangered metropolis in Europe. All disastrous earthquakes are generated within a small epicentral area that runs a source about 150 kilometers northeast of Bucharest. Thus, disaster prevention and mitigation of earthquake effects is an issue of highest priority for Bucharest and its population. Several buildings are monitored by the INFP, to which turnkey project added a total of 6 instrumented buildings with a total of 18 multisensor units and 5 GNSS instruments. The selected buildings are typical representatives of structures built under different seismic codes from 1930s to 1990s and for which the seismic vulnerability is unknown. Testbed 2 covers the Pyrenees mountain range, one of the most seismically active areas in mainland France. The two focus areas have been selected for the deployment of the turnkey multisensor units. One is the high-speed railway line between the Perpignan in France and Figueres in Spain, where 6 multisensor units have been deployed next to the train tracks with the objective to complement the existing seismic network with collecting strong motion recordings at the tracks. The other is the valley around Pyrenees de Lucian, where turnkey multisensor unit stations are deployed on 3 critical structures in order to assess their dynamic response in case of an earthquake. Testbed 3 consists of the towns of Hveragerði and Húsavík in Iceland, with a total of 50 turnkey multisensor units and 6 turnkey GNSS instruments to be deployed to improve the high spatial resolution of array ground motion recordings in urban areas, and to densify further the near-fault strong motion recordings in the transfer zones to ensure consistent near-fault coverage of the entire seismic wavefield on rock sites, and to evaluate and optimize the feasibility of earthquake early warning. The turnkey network in Iceland was given a comprehensive test during the recent and ongoing volcano-seismic event that started in February this year in Southwest Iceland, the subject of 2 other presentations at this conference. The testbed 4 is the most seismically active area in Greece. It's the Western Gulf of Corinth and the Gulf of Patras. It includes the Patras city and Ion town and focuses on school and public buildings. It aims to densify the existing arrays in the major Achaia region, involving also structural multisensor monitoring in a pilot school building and GNSS monitoring of the Aia Traíada fault that spans the south-central Patras city. So far, several events have been recorded by deployed stations, and the deployment is still ongoing due to COVID-19 lockdowns and special conditions in schools, as is common in all testbeds. Now, being located in the middle of the Mediterranean Sea between the Suez Canal and Gibraltar, the testbed 5, the seaport of Giotaro, is one of the largest and busiest transshipment hubs in the Mediterranean Sea. The port is located in the province of Reggio Calabria in southern Italy on the Tyrrhenian coast, which is a seismically active region with high seismicity. Hence, the port plays a crucial role in disaster relief efforts associated with the occurrence of an earthquake. A multisensor system has been deployed within the port area of Giotaro. 6 turnkey multisensor units and 4 turnkey GNSSs that are connected to them were installed for the recording seismic ground motions on the wharves, and as for structural health monitoring of the port and the strategic building for traffic control. Finally, testbed 6 covers the Groningen area, a province in the north of the Netherlands, where earthquakes are induced by production from the largest European gas field. A large free field vibration monitoring network has been installed in the region to define shake maps and improve the accuracy of the seismic hazard caused by shallow induced earthquakes. A structural vibrations monitoring network has also been installed to be able to monitor vibration of buildings. However, a monitoring network for infrastructure is still missing in Groningen. Thus, the aim in testbed 6 is to densify the existing sensor arrays and to install the newly developed turnkey stations on critical infrastructure, in particular bridges, viaducts, and water locks. Thus, to conclude, a total of 132 turnkey multisensor units and 26 GNSS instruments are being deployed in 6 European testbeds. They partially address specific weaknesses in existing sensor networks in each testbed, thus improving local and regional seismic monitoring. They secure and demonstrate the real-time streaming of various geophysical markers in a consistent data format to a central SEISCOM server. They continuously feed parametric data from the testbeds to the turnkey platform that enables a consistent approach to improved earthquake early warning and rapid response to earthquakes. The infrastructure development also facilitates future integration of multiple other geophysical markers, thus contributing towards operational earthquake forecasting advances in the European testbeds. And with that, I thank you for your attention.